This video is proving trig identities 2. We're going to look at how to prove a trigonometric identity. I recommend watching proving trig identities 1 first. We're going to try and prove that tan theta plus 1 over tan theta equals 1 over sine theta cos theta. First thing to do is set up left side, right side, separated clearly. The left side is tan theta plus 1 over tan theta. And the right side is 1 over sine theta cos theta. Okay, well, need a formula sheet handy, something like that. In particular, I noticed that the right hand side only has sine and cos, so I want to get the left hand side to just have sine and coses. Well, we can do that because we've got this formula here, tan theta equals sine theta over cos theta. So I'm going to replace, don't forget your equal signs, I'm going to replace my tan thetas with sine theta over cos theta. So the first one replaced, and this one is 1 over sine theta cos theta. Tan theta just became sine over cos. My next step, I'm going to leave this first fraction alone. My next step is to recognize when you're dividing by a fraction, it's the same as timesing by a flip. That is, 1 divided by a fraction is the same as 1 times cos theta over sine theta. And eventually you can just jump right from here to here, skipping this line. It's the same as sine theta cos theta, and 1 divided by a fraction is the same as the fraction flips. So 1 times cos theta, you just get this. Take a moment, can you see how to go right from here to here? 1 divided by sine theta cos theta is just cos over sine. But we're not done yet. Since I've got cos theta for the first fraction and sine theta for the second fraction, I want to do common denominator. What's my common denominator going to be? I'm going to want a sine and a cosine on the bottom of both fractions. Which means this first fraction, which only has a cos on the bottom, needs to get multiplied by sine times sine. So you're going to get on top sine times sine, which is sine squared. And on the bottom, cos times sine, that's sine theta cos theta. Cos times sine is cosine or sine cos, doesn't matter. This second fraction, I need to make it a common denominator too. It's missing a cos, so I got to multiply the top and bottom by cos. And when I do that, on the top I get cos times cos, it's cos squared theta. And on the bottom, sine times cos is just sine times cos. I'm going to put an arrow because I'm running out of room. I'm going to go up here, put an equal sign. Now I have common denominator. Since I have a common denominator, I can combine them. So this is all one fraction, sine times cos on the bottom. But on the top, I add the numerators because it's adding. So I have sine squared theta plus cos squared theta. And beautiful, I recognize that. Sine squared plus cos squared, that comes right from your formula sheet. Sine squared plus cos squared is equal to 1. So the numerator, which I wanted it to be that, the numerator just becomes 1. And on the bottom I have sine theta cos theta. Look, I got it. I'm done. But I have to write a concluding statement. And you should write it in the format since, which is an upside down therefore. Since the left side equals the right side, therefore, it's been proven true. And that's it. You've proven a trig identity.